So we are the A team, also known as Team Atlanta. The first thing I want to talk about was a basic statement about our communication. Our team spans 15 time zones from Stanford, California to Beijing, China. So a big thing that we're going to talk about throughout this entire presentation is how our communication evolved throughout the process. Before we do that, we wanted to meet the team. We first want to meet our two stubborn architects, Bryce Carter from Stanford University and Damien from Aalborg University as a grad student. Moving on to our structural engineers. You can do it. We have Ming and Marcella, both grad students here at Stanford. The men with the money, the construction managers, are myself, Andrew from the University of Wisconsin-Madison, and Pei Yao from Tsinghua University in China. Last but certainly not least, our mechanical, electrical, and plumbing maestro is Joao from DTU. On top of that, we also had 4 great owners, one of which is with us here today. Okay. We have Nikia, she was our CM owner, who is here with us. We have Michael, our structural engineering owner, Jakob, our architect, and Sebastian, our MEP.
So a few words about our site. It's located in the Midwest part of the US, in the Wisconsin, in the city of Madison, which is also the capital city of the state.
More specifically within Madison, the site is located on the north side of the University of Wisconsin's campus in the south shore of Lake Mendota. Getting into more detail, we saw that from all 4 directions, there's something unique about our site. From the west, we have the Lakeshore Path. The north, we have the picturesque Lake Mendota. From the east, we have the waterfront, including the Memorial Union Terrace. And from the south, we have Muir Woods, the Hill, and College Library. Bryce? Bryce, you there?
Can everybody hear me?
Yes.
All right, sorry, I lost internet. Okay, so as a team, we've had an interesting road to our final product, to say the least. Although 7 different building designs and countless iterations of floor plans are a good measure of the amount of work that we have produced, they are not good measures of team process and growth. When looking at the communication history of our group, we saw a very unique correlation between the amount of communication and the quality of our design. The first design, Containers of Power, was one that we came up with at the kickoff, but was strictly an architectural idea in which we were thinking about sustainable design. This idea was quickly dismissed when we tried to fit the program within the restricted size of shipping containers and had no chance of working. Next was the Cave, and as you can see from the timeline, our communication was at an all-time low. This is because we were simply working in our silos and communicating privately within disciplines rather than publicly across disciplines. It was a produce and react rather than a collaborate throughout. A couple more iterations in this space, and we finally realized that we needed to change. So midway through the quarter, we had a pivot. We conducted a brainstorming session with our team and came up with a collective decision to use transition as our next big idea. In this design, we really wanted to achieve transition throughout all disciplines. Examples included a transitioning facade, a hybrid steel timber structure, innovative MVP systems, and a proactive construction process rather than a reactive one. As you can see, our communication was at an all-time high. This was a great step in the right direction, but again, we wanted to achieve more. Because of its popularity in the earlier stages of the class and its inherent integration characteristic, we decided to start over with Shang Shui. This integrated building design is what we are proposing today and was produced in what we feel was a fully transparent and collaborative cyber working environment.
So we wanted to go back to our site real quick because we have a lot fewer hazards than other sites do in this program. Because of that, we wanted to focus on the user environment in all 4 seasons that happens in Madison. The fall with the trees changing colors and football season upon us. With winter, with snowfall and freezing temperatures, we want to focus on thermal insulation and also allowing the building to look architecturally sound in the snow. Moving on to spring, while trees and flowers are blossoming in Madison, we want to make sure that our building does not take away from the beautiful background it has on it. And finally, in the summer, when Madison is most vibrant and exciting, we want to make sure our building does not take away from the waterfront that it is placed on.
As said before, in this place we experience a humid continental environment, and the main seasons we have focused in was the spring, where we have
most of the wind coming from south, and also winter, and summer where we have wind mostly coming from northwest. Also, we have a low sun path in general, especially during winter, but during summer we have a good light conditions. The average temperatures, or let's start with the maximum and the minimum. We can have really extremes in our building sites. It can range from 85 degrees to -10, but most of the time it will be between 32 and 68. Also, we have a heavy snowfall, especially during winter. We have also rain throughout all the year, but especially in the summer period.
While we don't have hurricanes or earthquakes or anything like that, our site still has its challenges, its hazards, and its opportunities. The challenges our teams faced directly was a very tight site and was about 3 times the size of our footprint for our building. The way we dealt with that was a constant communication between the architects and the CMs. A diurnal temperature variation between summer and winter not only affected the architectural, the MEP, and the structural engineering, but also the construction management for the safety of our workers. The last big challenge we saw was pedestrian traffic with the lakeshore path. Keeping this path open throughout the construction process and after the building is open was a huge priority for us. The hazards we faced, as I said, were not as extreme as other teams, with a high water table, low overall sun exposure, and the weak soil types below our building definitely influenced our designs. In terms of our opportunities, the big one we had was Lake Mendota, one of the most picturesque lakes in Wisconsin. This lake is used 365 days a year, whether it's for sailing or snowball fights, and it's always a big architectural element within the city. Some further opportunities that we saw when we were looking into our building designs was the outdoor culture of Madison. It does not matter what the temperature is or what the weather is, people love spending time outside. Muir Woods to our west and our southwest also allowed us a very natural feeling environment around our building. And Memorial Terrace to east was a good counter with urban culture about sitting on a terrace right by the lake. The last thing we wanted to talk about was the Wisconsin idea, which is an idea held by the University of Wisconsin that education should influence people's lives beyond the boundaries of the classroom within the state. We really took this idea to heart, especially in the construction management portion, in order to focus our material locators in the state and support the economies of the state.
So our architectural concept is 山水. Try to pronounce it if you want. 山水. Yes. Literally, it means mountain and water. But in the view of Chinese poet, it means the wonderful, ideal space. As a building, 山水 means harmony with the nature. Live in the nature, do not destroy it, be sustainable. By the way, this word 山水 in Chinese sometimes is used to describe twice friends working together, just like our team.
So when it comes to the process, we started with the 100 by 100 square footprint and extruded up to create a cubic mass. Considering the name of our building and our heavy emphasis on integration, this building needed to be integrated into our site, so naturally we embedded the mass into the hill. But this wasn't enough because there was still no integration with the second word of our big idea of water. So using the idea of flowing water, we created a continuous circulation path that cuts its way in and out of our building, giving the boxy mass an organic and dynamic element throughout.
So now when we know what driven us to our design, let's go to the level. Level 1 is an open space. It's the accessible space for the user, but also for the pedestrians. We have the main entrance for the northeast side, which lets us go to the building and also access to the woods. This is also the place where we start our journey. We walk. Okay. We start our 2 stories. We continue our journey to the building. We exit on the east facade, and then for the first time, we enter the mountain to the cave. Now, we are focusing on the integration between the students and the faculty members. We have student offices and the office for the faculty members, but also we have clusters. The spaces where they can easily reach themselves and to change their works. We continue our journey from building. We go out on the north facade, make a U-turn, and then we reach the top level, which is on the west side, dedicated for the administration. And over there, we have a cafe with a lunch for the students and for the faculty. So we have 3 steps of the integration between the users and the building. This is also the place where we end up our journey and we enter the new routes. This was the hiking through the mountain. When we go down, we will be having the water flows down to the Lake Mendoza. Another important aspect for our team is the collaboration between architects and MEP. The main focus for us at the beginning was daylight. Because it's a university building, we had to focus about good lighting conditions. So most of the offices are located on the north facade with a picturesque view of the Lake Mendoza.
Though we have more than 70% of the building area, more than 250 lux, which is almost enough to have good lectures and a good environment. We also performed the Rhino grasshopper study about glare, and we noticed that especially during the summertime, we will have a fair amount of glare on our west facade, as we can see in these 2 pictures. And in order to deal with that, we are installing shadings, roll-up shadings, that will automatically open and close according to the necessities. Also, we will have natural ventilation, not only through the auditorium, with the help of the stacking effect that we will experience in the shaft. Also, we will have the same happening in the 2nd floor and on the 3rd floor, as we try to, with the architects, integrate as much as possible the building with the site to take advantage of the good things we have. Yeah, so our site is really nice, so we couldn't play with the building, and we didn't want to take a lot of space for the waterfront. That's why we decided to adapt the building to the wind that comes from the northeast to improve the ventilation. And the last thing is we know it's more about the biophilia building, but also we will discuss with our MEP how we can cooperate and create a better feeling and feel the forest that we have above. Returning to the climate conditions, we noticed that if we have a very compact design on our building, and if we reduce as much as possible the thermal losses, we will get the best results possible. So after calculating on eyes the energy demands of our building, we figured out that we will need mostly the most energy we will need will be in heating and ventilation together. This will happen because we have the heating and cooling systems going through air. The miscellaneous, it's all the computers and all the systems we have, server rooms and so on in our building. After all, in medicine, there is a fair amount of in that place, people rely too much in fossil fuels, such in the coal generation plant, but also in Wisconsin, there is a big use of coal. So we managed to use 26% of, we managed to use renewables in 26% of our total demand to satisfy our needs. And this is the total system scheme. It became naturally, as we started to study and to know better our systems, our primary systems will be the cogeneration facility, PV panels, photovoltaic panels, solar collectors as well, and we will have earth tubes as well. For the secondary systems, we will have displacement ventilation and also regular ventilation. For the displacement ventilation, we will have we will use it in the places that there is enough floor to ceiling height to have stratification. So it will be a study room that has a double floor and also an auditorium. So yeah, we try to merge our mechanical system as much as possible with the architecture and with the structure in order to get the best out of everything. So in the first floor, we have our mechanical room in the southeast facade, in the southeast part of the building with the vertical shaft. Here we will have, for the displacement ventilation we just talked about, we will have 2 holes in the slab so we can have ventilation from the floor. And on the second floor, we will have the 2 ventilation grills on the floor, as we said before, and the VAV boxes will be are installed by areas and not for a specific room. This way, we can use rooms with the same characteristics, with the same VAV box, so we will have the same kind of climate in the same kind of office or area. On the third floor, the biggest highlight will be the air return grills in here, in this area. These air return grills will be the return system for our auditorium from the displacement ventilation in the shaft. Displacement ventilation will be the ventilation supply, the air return ducts will be really small because it will be functioning in the plenum, or that's the area between the ceiling and the false ceiling. On the fourth floor, the biggest highlight will be the air handling unit with the fan coil unit that can cool or heat up these areas because there is too much or there is a lot of glazed area. So while we may need to cool down in the first floor, we may need to heat up on the fourth floor or vice versa. So our procedure to make the air systems, we started out first with the air supply and the return air in the same in a very typical way, and then we found out that it would take too much space. Then we tried to merge it with the structure, and we also found out that with blue lamp beams we cannot have enough big enough holes to accommodate our MEP ducting. So we used the blend. So it goes. We create a low pressure in the plenum in order to bring the air in the return system. About the renewables, we did again a simulation in Rhino Grasshopper. We tried to figure out where we need the most how can we use the sun as much as possible, and it was in the roof with most hours and most energy hitting the roof. Then we decided to have photovoltaic panels and solar collectors. One will be in the PV panels will be in the west side and solar collectors in the east side, close to the vertical shaft, and also an access area in blue for maintenance and all this kind of changes. We have to change twice a year the pitch of our solar panels in order to take more advantage of the sun, but also to prevent that the snow will be there. And that way we don't end up like John Nelson taking by hand all the snow from his roof. So we managed to have most of the energy for heating from our solar devices. We cannot have all the energy from that because in the winter there will be too few sun to take advantage and use all the potential of the system. We will also use kinetic plates. We will have 50 kinetic plates that harvest energy from the footfall in the entrance of the building, the place where more people will be passing by. In total, if 500 people pass through that area, we will get 340 watts. And now you tell me, yeah, that's a very low value, but it's enough to power a screen that will give real-time information about our building sustainable data and our building way of solving problems. We will also have earth tubes. The objective is to have ducts passing through the ground and use the energy from the earth to eliminate these peaks of air that are entering our air handling unit. We discovered also that in Wisconsin there is a platinum LEED certified building that has exactly this system, and we are pretty happy to have the same.
Okay, so for our software system, we are going to implement steel reverse hybrid system, and for the gravity resisting system, we are going to use steel frame and PLP4 to fabricate it with the Goulam beam. For the lateral resisting system, we are going to use precast high-coated fly ash concrete shear wall. So fly ash is one of the main byproducts of the coal combustion, and in Wisconsin, the major energy resource is coal. So by using this high-volume fly ash concrete, we can definitely reduce the waste, and also we can reduce the carbon emission by like 60% if we compare it to conventional concrete. So all of our materials are really sustainable, durable, and most importantly, integrate really well with the architectural vision and our beautiful site. We also make sure that the construction system is efficient by using the prefabrication and panelized construction. So due to the dark side, 3 stories of our building are emitted into the field. And due to this, we have to really provide a really strong retaining wall with 3 layers strength anchor to resist the heavy lateral earth pressure. So the installation process will include the solder pile assembly, and then the penetration of the strength anchor, and finally the placement of concrete using shock frame. For our foundation system, we're going to use isolated footings. But notice that during the winter, medicine will have a frost line that is 5 feet below the ground. So our perimeter footings will also be embedded 5 feet below, and then the insulation will be provided on the outer side of the footings. We choose to use high volume fly ash concrete for all of our concrete components, including our footing system, our retaining walls, and concrete shear walls. As mentioned earlier, one of our main challenges is the tight site, and also medicine snow started early in the winter. To make the construction process faster and easier, we decided to implement prefabrication and panelized construction.
So we propose to use the CLT floor panels prefabricated with glulam beams attached. So after the steel frame is in place, we can just install the floor plus beams. It is estimated that the prefabrication system is going to shorten the assembly time by about 3 weeks. We also did an ETAP structural analysis, and the models and our results are shown here. So our graphic system is satisfactory, and our lever system gives a max root displacement of 0.3 inches, which is well within the max limit of floor limitations.
So for our design look, we are taking that from AEC 710, and we have the wheel look and snow look. And here are our training plan. And as you can see here, our biggest challenge is actually providing a really irregular brick system to match the architectural concept. So on each slide, if you look at the left-hand image, you can see how our structural system interacts with our architectural floor plan. And also notice that the spacing between our glulam beams are capped around 5 feet, because the max width you can fit into a truck is like 10 feet. So effective spacing will ensure that a 10 feet wide CLT panel will have at least 2 glulam beams pre-assembled. And these are details, typical details included in our drawings.
For the construction management, Andy and I at CM want to focus on the challenges of our site. We want to use these challenges to directly influence our design. The first challenge of our site is limited accessibility. With a single small entrance on the east side of our site, it becomes crucial for us to use a singular path to access to avoid any crowded area and sharp turns. And to further our site accessibility, a detailed delivery plan will be used. GPS-based real-time tracking systems with our detailed delivery schedule will help us minimize the delays caused by the site congestion.
In terms of our more site logistics, because of how small our site is, with about 150 foot wide by 200 foot long site, a mobile crane with this square footprint became impractical due to the issues getting to the west facade. So we had to go with the tower crane. Luckily, because of our steel and timber construction, our largest panels were well within the range of any basic tower crane. So we were able to focus more on the footprint size and the erection time of our tower cranes, and we came up with the Lever ECB5 tower crane to use. Some other equipment we use on site, due to our large amount of excavation we have to do by embedding this structure into the hill, we'll be using excavators and haulers to move the soil from the site. For our interiors, we'll be using forklifts, and our facade, which we'll talk about later, we'll be using telehandlers to move our panelized construction up to the correct floor. Our overall site plan had to stay simple because of how small our site was. With working with the architects, we put the footprint on the west side of the site, with the tower crane on the southeast portion of the footprint. This not only maximized the amount of space that the tower crane can reach on the footprint, but also minimized the amount of crossover with the pedestrian walkway, which will be staying open the entire time during construction. Putting offices and toilets in the southeast corner of our site allows a second path behind the Water Resource Engineering building for workers in order to avoid crossover with trucks and crossover with the crane.
The second challenge of our site is site safety. As our site is very tight, the collisions between workers and vehicles happens. So we decided to apply sensors like RFIDs on the equipment so that we can update the constant location information of the vehicles, and using this to make the management notice what equipment will be, so that to ensure the safety. And due to the cold winter of medicine, wearable devices in PPE can help the management notice and monitor whether the workers are safe and healthy, so that they can work safely. The last but not least challenge is about participant safety. As the lecture part is on the north side of our site, and we have a library nearby. So we want to use kind of fence to keep safe space for the participants and eliminate the noise at the same time.
Like I said earlier with the Wisconsin idea, a big thing we came out and I wanted to focus on was getting materials from local suppliers. While that does not mean necessarily that the materials will come directly from Wisconsin, by supporting local businesses, we are allowing the economy to grow in Madison and Milwaukee, and allowing Wisconsin to continue to grow as a state. Our TBD evolution is a bit of a mess because of how many iterations of Sean Tree we actually had. It was a lot of general estimating because we never really got a finalized floor plan or structural system through our first few iterations. However, after our pivot around the 30th of March, we were able to start integrating our complicated Dynamo script and allows for accurate takeoffs of what was going into the Revit models. Our final TBD estimation ended up about $400,000 below budget, or below our target value, which ended up being $600,000 below our overall budget. The big takeaways from this is that our shell construction was still under budget, and because of the lack of a return air system, Joao was able to pay for his PV panels with that money and still stay under budget. Bryce, you there? Bryce?
Unmute.
Everybody?
Hello, Bryce.
Hello.
There we go. We can hear you now.
Go ahead.
Okay, Bryce, last chance.
All right, can you hear me?
There we
Yeah.
go. Yeah.
All right, sorry, that's bad. Okay, so at this point, we have purposely left out one of the most important aspects of our building, and this is because we see this element as the pinnacle of our team's collaborative development over the last 15 weeks. The facade was a challenge from the beginning, but a challenge that we tackled as a team with all discipline inputs being heard, understood, and utilized in the final design. Our building initially started with a fully glazed facade system. At the winter presentation, we got very positive feedback from the visitors on all major characteristics of the building except for the facade. So moving forward to the fishbowl a little over a week later, we decided to ask the question, what should the facade be? As you can see from the confusing screenshot of our span during the fishbowl, no real answers were given. A common theme was that it was possible to do, but we should probably think about it.
No.
Right.
All right, Bryce, we can't hear you again.
Julie, and dive deeper into what he was saying and see if we could find a solution. His advice was the same, that we should start out with the facade, but he gave us 3 objectives and guidelines to keep in mind when designing it. One was we were going to shoot for 30 to 40% max building glazing. 2 was we needed to comply with building codes that we had failed to comply with earlier. And 3, we needed to put building.
We need to put performance for aesthetics.
So, existing facade with the guidelines above in mind and as a collaborative unit.
Cool.
So now, we told you about our biggest challenge in terms of the design. We can proudly show you our facade. So as we have 4 seasons in Madison, also we have 4 different experiences depending on the facade we are looking at. For example, when we approach the site from the east-north, on the waterfront, we see the building that erupts from the hill. But when we look at the building, when we are on the top, we can feel the coziness of the space. It's one-story building. It's a totally different experience.
Okay.
Well designed.
while designing our envelope, we have to keep in mind concepts such as air tightness, water tightness, insulation, and aesthetics.
So for our facade connection, we are going to use fiber reinforced polymer profile. The reason why we want to use this is because it provides a really good thermal insulation. Also, it provides high moisture and corrosion resistance. So the FRP angle will be connected to our perimeter beam using the poles, and then the facade panels will be attached to the angle.
So one of our building's distinct features is the cantilever ring that goes around our building. But unfortunately, it also creates thermal bridging issue. So to better insulate our building, we decided to provide the thermal ring that is made of fiberglass reinforced laminate composite to connect our cantilever red beam and the steel columns. So the thermal brick manufacturer for BrickHead is based in the US, and this product has sufficient strength to ensure strong integrity.
Because the facade is naturally made of panels, it makes sense to try to prefab these panels in order to allow for easier construction and avoid congestion on our tiny site. So how we do that is we put our facade's 20 gauge steel sheet on top of the insulation and skeleton on all three sides that extend out to the site. By doing this off-site, it allows for easy transportation and easy installation once it arrives.
Here is our detailed schedule and the body CAD showing how our building will be built up. All in all, our project will be finished by the end of July 2025. The whole duration of the project is 11 months. We optimize our schedule and save time by arranging parallel work as much as possible. For example, after finishing the columns, beams, and the floor of each floor, we will start the partitions of this floor as soon as possible to save time.
Finalizing out the construction management portion of our project now that the full building has been developed. We used BIM 360 glue as a technology to try to address clashes that we saw in the building, even though we tried using fast avoidance and Revit. The second thing we did was use a complicated Dynamo script to allow for automatic integration into Excel, and allows our TBDs, STBs, and ETABS model to automatically be updated. Because of our site's natural elements that we have around it, the last thing we wanted to touch on was how we're going to avoid contamination of the lake and the forest. The biggest thing we're doing is sediment traps to the north of the footprint in order to catch any sediment or construction waste that may enter the lake. The second thing we looked into is avoiding erosion of the hill due to our excavation. By allowing for silt fencing and fiber rolls wherever necessary on the south side of the site, we can try to minimize the impact that we have on the hill. The final thing we talked about was with our one entrance and one exit zone, we wanted to install a wheel wash to avoid any material escaping our site through truck wheels.
In our STB, we ended up with by hitting the targets in water and energy, but in CO2, due to the use of the cogeneration system using natural gas, we weren't able to reach the carbon minimum. But in another way, we have very, very good news. We used LEED certification, and LEED is more focused on building efficiency and on user well-being, let's say. And we got gold in both.
Similarly to other teams, we went through the past 10 years challenges when it comes to sustainability. As this year's challenge is integration, this is our approach and our answer for the past year's challenges. But what is more important for us, the integration is not only about the challenges, but also about the site and the people. And for us, as we had a really difficult way to get in here where we are today, as for us team, not only as professionals, but also as a friends. Thank you.
Hey Renata.
Hello, yes, good
Is
to
it-
hear your voice.
again.
Okay, you are in and out, right? Just keep in mind. We hear you with lots of, yeah, you are talking, but we cannot hear you.
Oh,
Okay.
gotcha. I was asking if you could move the mic closer to the mentors during the feedback so that I could hear them.
Okay, we'll
Thank
try.
Okay.
All right, mentors. Yes, Adam, Mike. Go ahead, Adam.
All right, so my first question, first of all, really nice presentation. My first question is going to be about this kinetic panels. I see that they save just a very small amount of energy. But like, have you considered the cost of producing them and like the energy spent for producing them? And the grand scheme of things, it's really the same happening there with the production energy and cost spent on buying them. Wouldn't it be cheaper to just purchase the energy instead of applying the sound?
The objective here is not about producing energy, it's about changing building user behavior. By not only by using these kinetic plates, we are just showing people that energy can be harvested in many ways, and also that that our building can be improved in many ways in order to get more and more sustainable. So if we have associated with that, if we have a screen showing data about our building, we can even have waste numbers about how many kilos people are separating, for instance, with that screen. It becomes much more valuable than the energy that the plates are. It's just the whole concept around it.
So I just want to say, beautiful presentation. It's through and through. I mean, usually I see a presentation, the architectural renderings, the architectural slides are beautiful, and then the structural side is ugly. No offense to anyone here, but it's from start to finish, a beautiful job. It was, you guys took a very disciplined kind of architect win, structural engineer win, and construction win, which was a little different than what we've seen other presentations. You guys did it very well. I think you pulled it off. It wasn't boring, or, it wasn't. It went through well. I really like the honesty in talking about DVD. It's a mess, and that happened, and that's the truth. You're not trying to sugarcoat anything. That's the reality. So I really love that. I actually sat in your guys' session months ago. It was really, really awesome to see the challenges and things that we brought up then really being dealt with. And I noticed all of those challenges that come with that site. And speaking of on the construction side, the most challenging site on the whole class. So I think you guys dealt with those challenges really, really well. You guys didn't just say, here's our logistics, and here's our crane, and that's it. You really had a good explanation on why you went to prefab because of your space constraints, why you chose a tower crane because of the issues with reaching the other facade, which I think out of all sites, the tower crane doesn't really fit, especially with such a small project, but you guys really have a compelling argument, so we're really commend you for that. Thank you.
Yes, Dave.
If I could, the thing that struck me most about this, the words that were going through my mind is the whole is greater than the sum of the parts. And, what I liked about it was that not only the progression from a kind of modular containerized design at the very beginning to something that is incredibly poetic, through time. And then your discussion of seasons and how buildings change through time, how the architecture responds through time, how the mechanical and the other systems also respond through time. And so I thought that was a great organizer for the project, and it also reminded me of a book that was written many years ago that I think is still relevant today. It's called What Time Is This Place by Kevin Lynch. I'd encourage you to look at it, read that, get a copy and read the book. But it talks about how we experience places through time and various seasons. And I thought that, that that organizing factor really helped the design. I thought that the poetic nature and the juxtaposition of the box structure with the poetic path, had the opportunity to take you through space and time and kind of became more than the sum of parts. So I thought it was a beautiful solution.
Peter.
You guys told a very good story, which is very, very nicely done. Not only did you guys showcase the site itself through the design of the building, physically and metaphorically, right? Walking from the mountains to the lake, and how people flow through the building, and seeing that. I also really appreciated that with the explanation of the facade, right? It showed the amount of teamwork, and you guys all diving in into just one solution, how you guys work together and collaborate on just one particular solution. So that was very, very nicely done.
Yes, when you guys started out, the opportunities and challenges, it made me want to go visit Madison because I've never been. So,
You should, it's a great place.
Yeah. I gotta say, all of you guys' 3D images and sections, they were not just beautiful, but they were also very informative. And this is working great now too. Yeah, very a lot of great 3D communication that can tell a lot of the story and a lot of the layers of what goes into this, because sometimes we see our own individual, the architect renderings, the structural beams that you see each one individually, and seeing some of these 3D sections you guys had, put the whole thing together to see it really become a whole. The natural ventilation seemed very ambitious. I think the mixed mode, I think it's an appropriate opportunity to proceed with, and I think it kind of gives you the opportunity to try and account for as much space, but even though it was more complicated for you to work on, it actually helped the entire building as a whole. And that auditorium, I feel like I might be looking the other way at that green living wall instead of looking at the speaker. But I thought it was a very interesting approach to send that whole thing all the way up. And I think the stack ventilation could be feasible, but I was concerned about it, maybe hear from the MEPs about it getting stuck kind of over in the other area near the presenter. And I was thinking you could do something like a sloped ceiling that also helps with the acoustics there, which will also help maybe stop that air from getting trapped in that area. Maybe let the MEP weigh in on that later. At the end, I think the focus on the facade is a great story because to see you guys react to what you were hearing and what you were feeling around you, need to go find the focus and really hone in on that. And I think it was really great to see every different facade up here treated differently and have some type of approach. I guess I was curious, which one was the south facade?
Was this one for us?
Sorry, the one. Yeah, that makes sense. Okay. In that case, and I'm not going to take that comment off. Yeah, I think one thing that was really interesting to see, you guys go and pursue this.
But thanks for your work. I think you've done a lot of little gems in this project. Really special.
Any other comments? Yes, Pat.
So, a couple of things. I really liked the way you presented the evolution of your design. We clearly went through a lot of different variations on this. And I think it's really nice of you to present how challenging it is to go from the beginning to the end when you have so many different variations in the middle. And I think you did a great job presenting this. I do have a question, though, about the decision to go with a mix of photovoltaic as well as solar thermal. Often, when we do projects, we find that we end up doing one or the other because of various factors. Certainly in California, electricity is very expensive, so PV has greater utility. There's more impact on energy costs. In Wisconsin, though, solar thermal has advantages. There's no meltdown here. It's expensive.
But mainly because during the summer we couldn't use most of the hot water we produced. If we had all with only hot water, for instance, we wouldn't be able to take advantage of it during summer, for instance. But with all PV panels, we wouldn't benefit from better transition from sun radiation into heat, because the collectors are 4 times.
Also, I like the ramp. Kind of what you do in a maker, okay, like you're eating it somehow, like that. I really like the way it makes, I met two startups that are doing just that, and I think it's in the future, and I will bet that, I can 10 years that will be like that, of course, I particularly like the well building certification, which is of course like, not as old as established the league, but that's not the future in my opinion, because it's a lot of people, not just about the building itself. So I do have one question, and I haven't seen it in the last presentations. I'm a MBD specialist by any measure, but I see a lot of ducts, like, and I like them, and like there are like pressurized wagons, low ducts, which is much more comfortable, flexible, cheaper. So like, do you consider that or?
Yeah, we consider all these small things about it. Maybe the main driver was the lack of space. We would have like 8 feet floor to ceiling height. It wasn't acceptable. So we tried to look into different solutions, and we came up with this. We wanted solar panels and like use more expensive technology. So we made this exchange of having less return ducts and having more better solutions on the other side. And yeah, that's pretty much it.
And just one final comment, like I really like I think like you started on the exterior and then like even the interior is exciting, like functionalities and stuff, but sometimes those odd shapes like don't really work well, like for functionalities or functions and stuff. So like there's nothing to be actually built, like probably we can scale out a little bit of that. These guys can do it. So great job. Thank you.
On that note, thank you very much,
This one really interesting, okay? Would you just move a little bit so people can see this picture, okay? I mean, the presentation is well organized, nicely presented, very, very fine, okay? But the reality is that this is a falling image. This is a winter image. Look at the snow on the trees, okay? And there is no snow on the ground here. And your entry doors, glass doors, are literally down to the ground at the entry level. Where is the snow that has been cleaned? Where did it go? Okay? The removed snow, okay? Now this ramp, okay? As a ski official in the United States, the Ski and Snowboarding Association, I can tell you, I can set 3 slalom gates on that ramp. That's illegal, okay? If in the winter, you would never, you would have to close this off because you people would be falling and sliding all over the place. Come on. Now, I have a couple of other points to raise. Your natural ventilation section at one point showed long horizontal arrow, going from one end of the building to the other on the same floor. What is driving that movement over there? I don't see, in the winter, I don't see any pressure differential between the ends. There is not going to be any outdoor temperature difference. So there's not going to be any natural ventilation whatsoever, okay? And then you get, also your solar panels, etc., okay? Which I guess account for contribute to some of the 26% of renewable energy supply used in this building. Look at the trees, right, on the south side of the building. What kind of exposure are those solar panels going to get? Okay, minimum in the summer only. Okay, and then you get 76% of energy supplied from the grid, and the grid is supplied from coal. Okay, and you try to get gold rating for LEED. I'm not going to blame you. I'm going to blame like the lead rating system for giving you gold for this. Come on, all right? And also one other little thing, you have essentially created a system of many double facades on your facade. Now you have not indicated there is any ventilation of that. How are you going to ventilate that? How are you going to clean that?
But it's not the double, because.
Oh, it is, though yours middle, there was a section, there was a drawing here showing that you have two panels of glass like that with a panel of insulation over there. So that creates a little double facade, okay? You need to ventilate that. How are you going to do that?
In a place, because the glazed panels that are on the facade are frosted or transparent. In a place where they are transparent, there are offices, and then we have inside the building we have the glazed windows that are openable, so then we can clean the facade from the inside. But on other places, we don't need that because there is a wall.
Then you need to show that in the drawing that explains your system, because there was nothing showing that those interior glass windows were operating. Okay? And one can judge this. If this was a formal architectural jury or an architectural competition, you know, the information you supplied would kill you. Okay? So, but nice presentation.